Hello everyone, Siddharth this side, and in this video we will be solving another question on lead code, which is invert binary tree. So in this question, we have to invert the binary tree, or we can say if we place a mirror to the right side of this tree, then the image that will get reflected into the mirror, that we have to make that tree. So how we can solve this problem? So if you if you if you if you have solved the question which I had solved earlier, which is a height of a binary tree, so we will be using the basics of that questions. If I would suggest that first you will try to solve that question, and if you will solve that question, then generating intuition for solving this problem will be quite easy for you. So let's see how we can modify something into that code and we can able to solve this problem as well. So so suppose this is a tree. One, two, three. First take this tree only so that we can understand the problem well. Then we will take a little bigger tree. So what we had done in the previous question that we had solved, which is the height of a binary tree, in that we will first we will travel to the end of the node until we encounter the null, and then we will, after traversing to the left, then we will call to the right child, and here also it is null, so uh, we will be returning null root in this case. But in that case we have taken the maximum of these two, because there we have to take the height of the tree, but uh, here we have to revert the tree. So as the name suggests, we have to invert. So uh, by this name we will be getting clear idea how we can solve this question. Like, for the current node in the each recursive call, we can try to invert the left and right node. Currently for this node they are null, so we don't have to do anything, but for this one we will be having this 2 and 3. So instead of returning null, for the base case, in the general way, we can return the root to its parent, and in this way we will able to store these left and right node into true variable, which is tree dot tree node left and tree node right. Now we will store uh, these two nodes, we will store to its left and right variable, and we will try to swap these two, uh, and after that we will be making another tree, or refracting another tree by doing ones left to 3 and right to 2, and in this manner for each node we will swap its left and right child, and in this manner level by level we will able to invert the binary tree. And let's see, if we try to take a bigger tree. So let's take this, so 4 and 5. So first we will travel to the left until we encounter null, and in this case we will be returning null, and for this right as well we will be returning null. And now, after processing left and right, we will just swap these two, but here they are a null, so we don't have to do anything. But still we will store these two. So tree node left we will be storing as null, as we just have it base case, so we will be storing null here, and for tree dot right we will be storing null as well, because the right side is also null here. Now after this we just return this current root. So now this parent is waiting for its left call to finish, and also for this recursive stack, we will be having left as 4, and now it will call to its right child. Now again we will have to call for its left child and right child. They will both return null, and we will be swapping these for, like this we have done for this 4 node. So they are also null, so we don't have to do anything. Now we will be returning our current node, which is 5. Now for this node, we will be having tree dot left as 4 and tree dot right as 5. Now we just have to swap these two. So what we can do, as already we will be having these two stored right here. Now we just have to swap, like the swap logic that we generally use. We will do 2 dot left as right, this right, so that will going to be 5, and 2 dot right as left, which is 4. Now this tree will get refracted to 1, 2, and it will, 4 will become here, 4 will get here and 5 will get here. Now for level by level, for each node we will able to refactor this node. Now it's all the left and right call will get over, and it will return call to its parent. Now same we will apply for 1 also, that we have done for 2. Now it will move on to 3. Now this will return 3 to it, as there is nothing here. Now here it will return 2. Now we just refactor this also, so this will become 3 and this will become 1, and this will become 5, this will become 4. Sorry, this will get refracted again. So this will, okay, so this will become 3. Sorry, this will become 3 and this will become 2, and 2 dot right is 5 and 2 dot left is 4. So in this manner we can able to solve this problem. So let's code this out as well. So first, what we have to do, we just have to handle the base case. So if root is equals to null, we will be returning null. Now after that, we have to store the left node, and also we have to do the recursive call. So tree node left is equals to invert tree, and we will be passing root dot left to it. Now let's store the right as well and recursively call this function. So this will root dot right. Now after doing this, we just have to swap these two. So for each recursive call, we will be having as this as a root. For this, it will going to be 1. So what we have to do, we have to do root dot left is equals to right, and root dot right is equals to left. So this will swap the nodes. Now we just have to return the our root in the last. So now let's try to run this code. Okay, all the test cases have been processed. Now let's try to submit this as well. So all the test cases have been processed. So thank you. See you in the next video. Bye.